lesson in parabola. So before we start, let us have this opening prayer. Would you mind to lead the prayer? Kate? Angel?
Sir, can you hear me po?
Yes, po.
Classmates, are you ready to pray?
Yes, sir.
In the name of the Father, the Son, the Holy Spirit. Amen. Thank you, Lord, for the meal that you have given us. Make it help us to serve our brothers and to love you better. Amen. In the name of the Father, the Son, the Holy Spirit. Amen.
Amen. So thank you for that one, Kate. So let us now continue 10A about the parabola. Right? So let's start here already. Are we going to start here? Or let's make it a bit backward. Let's have it like in here. Let's have yeah. Okay. So what's next? We're going to find the focus. No, the focus. And in order for us to find what is focus, we're going to ask ourselves, no, whether what is the axis of symmetry? What is your axis of symmetry? Is it in x-intercept or y-intercept? Just take note from the equation that you have right now. This is just the same from the equations that you have at the first place. It's just that it was just added by h and k. Oh, what did you notice? The variable that doesn't have degree of 2, no, is the variable of x. So therefore, your axis of symmetry is at x-intercept, no, x-intercept, all right, so that is that. All right, so if it's in x-intercept, so you are uh, assuming that it's in here, and somewhat your directrix is in here or in here, no, so you're just assuming. Now, if it's in x-intercept already, you're going to find the value of c, and it will be located at the x-intercept, and your placement or focus is at 3. 3. All right. So how are we going to find the value of c? Isn't it that you have c just for your focus? So how are we going to find the c? So your c is coming from 4c, isn't it? So this is the value of 4c. So your 4c is equal to 4. This one, this one. 4 is your 4c, Now, if you have 4c, you're going to find the value of c. Okay? So therefore, you're going to divide both sides by 4 because the only thing that you need is the c. So therefore, 4 divided by 4 is the axis is, or the value of c is 1. So therefore, it is 1. Okay po? Alright. So positive. Positive. Okay? So, in this case, that is the c. Okay? So how about the directrix? Okay, so if you said that you have the vertex, what is your focus? Positive 1, positive 1, this is your positive 1, Positive 1, then, what's next? I'm sorry, negative, positive 3, positive 3. Is this your focus? Is this your focus? That's my question, Isn't it that we are going to add 1? Is that your focus? Oh, kindly take note, Why did we have 3 in here? We based from your vertex. So, if you're going to base from the vertex, please kindly take note of this one, what is the formula that we have just now? So, you have y minus k squared is equal to 4c. That is your 4c. The value of 4c is for a while ago, isn't it? So, your focus is dependable on the vertex. What are your vertex? That's the question. Okay, so if you have one, let's clear this up. If you have one, please write your vertex first. Negative 2. Okay, negative 2. Isn't it? That is your vertex. But you are going to add 1, add 1 to your x. So it will become just like this. So instead of writing x squared, x and negative 2, then 3, just try to add 1, then 3. So what is the value of negative 2? When you add 1, what's the value? It will become negative 1, then positive 3. So that is the value, no? That is the value of your focus. This is your focus, okay? Not this one, all right? All right. So in this case, all right. So if you have the value of 1, because that is the distance, isn't it? That is the distance coming from your vertex and your focus. How many counts or how many points did you were you able to count? You only have 1. That's why our C is 1. That is the count of the distance of your from your vertex to your focus. Okay, gets. Oh, when you have positive 1, when you add 1, you subtract 1 for your directrix. No, from your vertex, no, from your vertex, uh you subtract 1. So what is your vertex? Negative 2, negative 2, then you minus 1, then 3. Oh. Negative 2 minus 1, what's the answer? The answer is negative 3 already. So that's why you have negative 3 and positive 3. It's negative 3, then positive 3. So this is the directrix. No, this is your directrix. This is your axis of symmetry, axis of symmetry. So how are we going to find the latus rectum? You have the values of 1 or your C, no? So we said that one of the half of the latus rectum is equal to 2C. Okay, 2C. 2C is equal to the half of latus rectum, no? LR. LR, ha? So, in order for us to find the latus rectum, no, that is just the statement, ha, that we could just simply have the 4C in total. But in this case, the value of your C, when you multiply the value of your C by 2, what's the answer? Oh, the answer is 2, of course. So your 2C is equal to 2. Okay, so you have the value of 2. So you count 2 upwards. You just have LR, ha. LR is equal to 2. Half of the LR. Half of the LR, let's just write it down nicely. No. So we could tell that 2C is equal to 2. So you count 2 here at 2. Alright, so therefore this is your latus rectum already. So let's just erase this thing. Okay. Alright. So this is how we graph our parabola. Alright? That is how. And that is our latus rectum. Okay? So the one that I'm writing a while ago, it is the coordinates of latus rectum. And how are we going to find the coordinate of latus rectum? Based from your focus. What's your focus? It is negative 1. Ha? Negative 1. So, from your negative 1, you are what? You're going to, from your focus, ha, it is negative 1, then positive 3. Oh, your 2C, you're going to add the value of 2C, which is 2. You're going to add, then subtract. Sorry, this is not for focus. Your directive. You're going to add and subtract from the focus itself. So if this is the focus, negative 1, then 3. We're going to add and subtract, no? Subtract 2 for your latus rectum. Okay? Alright, so but if you will going to find the distance of latus rectum, the value of it is what? 4. Okay? Alright, so I hope that you we are clear with this one. Last example. Let's example ha. This is the last example. So let's have this example. What is your vertex? The vertex is -3. This is your h, and this is your k. So the values of your h and k are +3 and +2. So in this case, we're going to find the focus. And from your focus, you need to find the value of c, isn't it? So in order for us to find the value of c, you need 4c. What's the value of your first 4c? It's 8 or -8. So 4c is equal to -8. And in that case, you could find the value of c by dividing both sides by 4. And no, that is why you have c is equal to, what's the value, what's the quotient when you divide -8 by 4? The value is -2. Okay? So, your vertex is placed at +3, then 2. Okay? So, if this is the case, ha. Your focus, or you have the value of c is -2, ha. I will be erasing this one. Your focus, you take note ha, where are you going to base to get your focus if you have the values of h and k? So, based on your vertex, what is your vertex? It's 3. 3, then 2. Ask yourself first, what is your axis of symmetry? What is the axis of symmetry? You will notice the degree that has squared is the value of x. So therefore, the variable that doesn't have any degree of 2 or the degree itself is y. So therefore, our axis of symmetry is y. No, y intercept. Okay? So therefore, where are we going to add this? Where are we going to input this -2? Where are we going to input? That's my question. Where are we going to input? We're going to input at where? Y-intercept, of course. You're going to add. You're going to subtract. We're going to subtract 2, this is the value of 2, to your y-intercept. This is your y-intercept, this is your x-intercept. Now, from the focus, we are going to plot what is the value of your focus. It will become 3 and 0. So where is your focus located? So it's 3 and 0. This is your focus. This is your directrix. This is your vertex, isn't it? So if you have the value of 2 for your C, your C is -2, and your directrix, no, should be a +2. Why it becomes +2? Isn't it that we mentioned that the directrix and focus are equidistant to each other from the vertex. So our directrix is +2. So you're going to add 2 to your y-intercept. So coming from your vertex, what is your vertex? It is this way. If it's in y-intercept, if it's in directrix, please take note ha. It's just simply the same. Wherever you input or wherever you add, subtract, your c's, no. So that is where you're going to change as well. So from the vertex, you have 3 and 2, isn't it? So in this case, from your focus, you subtract. So in this case, you're going to add. Okay? So if you're going to add, the value of your directrix will be 3, then 4. Your x is in the 3 and y-intercept is in 4. So it will be 4 comes from 3 and it will be 4. So you will notice the the value of C, or the distance between the directrix to the vertex, is just the same with the focus, and they have the values of 2. No? Alright, so this is our directrix. Okay, so axis of symmetry is y-intercept. So probably your graph is just like this. Okay, so how are we going to identify how wide is your graph? Or how are you going to know? By using the latus rectum. For your latus rectum, how are you going to find the values of latus rectum? From the values of 2c. Okay, 2c is the half. Please take note of 2c is equal to half of the LR, or half of the latus rectum. Okay, so in order for us to find the value of latus rectum, if you're going to solve this one, if you want to solve, you just need LR. So you just need to cancel out the values of 1 half. How are you going to remove 1 half in there? So in order for us to remove, you just multiply both sides by 2. So it will become 2 multiplied by 2c is equal to LR. Correct? That's how, but in this case, we're going to find the values of 2c. What is your c? Your c is negative 2. Okay? But in this case, no, it is in absolute value. Okay? It's an absolute value, because when you have c's, that is what we call the magnitude, or the distance between sides. Okay? So if you have the distance of 2, and when you multiply it, what is the value of c already? So when you multiply 2, it will become 4. 4. So therefore, you have, coming from your uh, focus, base on your focus. What is your focus? Your focus is 3 and 0, 3 then 0. Okay. So where did you add and subtract your from in the vertex? The vertex, isn't it? From your vertex, you add and subtract in order the C, in order for you to find the focus and directrix. But in your latus rectum, you're going to depend on your focus. Okay, so the question is, where are you going to add or subtract? Is it in x-intercept or y-intercept? You're going to depend on x-intercept. Okay, so you're going to add 4, because the value of 2c is 4. It will become 3 plus 4, 3, negative and positive 4, and 0. So when you add 4 at 3, the value is 7. So 7, 0, this is the one. And when you subtract 3 by 4, 3 minus 4, the answer is negative 1 and 0. Okay, that's why positive, negative. You add, then you subtract from the focus. No. So you will be having negative 1 and 0. So let's just count. If the value of your 2c is really 4, no? So you have, coming from this one, let's count. 1, 2, 3, 4. Correct? Is this 2c correct? Correct. How about the other side? Let's count. You have 1, 2, 3, 4. Is it 4? So this is correct. No, so in other words, our lactus rectum is equivalent by 8. Okay. In total, it's 8. So we are going to graph it already in this manner, or just like this. Okay, just like this. Just like this. That's how we graph parabola. And I do hope that you learned something in our discussion right now for the conic section, which is parabola. And I'm wishing to see you in the next video. Alright, so thank you once again, Drayton. Hope to see you in the next recording. Alright, so with that, that is for the parabola, and I hope that uh, you somehow get the concept of how are we going to graph, no, the parabola. So this is where I will be asking already. No? So if we are going to have, please listen na, if we are going to have an equation of the parabola, please listen na, if we have x squared is equal to 16x. May I ask you, what is our axis of symmetry? Again, this one. Y squared, y squared, y squared is equal to 16x. What is our axis of symmetry? Let me ask Francis. If we say y squared is equal to 16x, what is our axis of symmetry?
X po.
X, correct. How about if we said x squared is equal to 24y, what is our axis of symmetry? Zyril. Zyril. Mambat. Zyril.
No po, sir.
Yes, sir.
Ay,
Again, I will be telling. If we have x squared is equal to 24y, what is our axis of symmetry? Go, Zyril. That's fine.
I don't know po, sir.
Axis of symmetry, ha? We say axis of symmetry. Yes po. Oh, Akira, you're trying to help.
Sir, why po?
Yes, it is correct. It's y. Please take note. Um, in circle, if you will remember, both x and y has squared, correct? Even in ellipse, they have squared. But when we are talking parabola, we only have one variable that contains square. No? Why? If you will notice, a circle is a closed shape, correct? So it means if I have two hands, the left and the right, okay? So if we are going to combine them and perform a circle figure, this contains half of my hand, correct? So just like in parabola as well. So even though we form a parabola, we have two hands. But when we have parabola only, we only have one hand. So it means if you have left and the right or x and y, no, either your x has the squared or y has the squared. Okay, so it only performs in one direction, but it will not close. Okay, because it is open. Okay? So that's how we are going to identify whether the equation is a parabola. Because in the exam, if you will be seeing something like identify whether it's a parabola or ellipse, hyperbola, circle, or whatsoever. Okay? So coming from the general form, if all of the given in there is in general form, first thing you need to do is to make it in standard form. You just transpose, okay? And one thing in circle, if we're going to go back in circle, in circle, we only have the x and y, correct? And the center of it. If your x has h and k, therefore you do have center. The value of center is not in the origin, it has value. And you're just going to look for the radius. And radius, you're going to refer, if you transpose from general, if you transpose the constant, if you say constant, that is the number that doesn't have any variable with it. So if you transpose it to the other side, that is your radius. But what if you have general form, x and y, then you have constant as well. But you have coefficients like number beside the x and y, that is ellipse. Okay? I will be writing it down so you will not be confused. Okay. try this one. Don't mind this checking of homework, huh? Alright. Okay, so let's try this one. So if you just see x plus y squared, then a number that is a circle, correct? Okay. But if you just solve, for example, x squared plus y squared plus 4 is equal to 0, that is a circle. Okay, why? Because you have constant. You could just transfer. Okay? All right. But what if you have, let's just say 4x squared, then plus, let's just say 7y squared, then is equal to, let's just say, is equal to 28. Let's just say 28. Hmm. This is what we call as ellipse. How did we say it's ellipse? Isn't it that in ellipse, we have x squared, y squared is equal to 1. Then there's a denominator, correct? Correct? P squared, p squared. So, in order for you to have the standard form, if it was in general form, you just try to look. Oh, you need to find the value of 1. So, in order for it to become 1, you just divide it to itself. And once you divide it, no, in your right side, if you divide something, you also divide to your other side. So, therefore, you could have these two fractions, no? You could just separate them like 4x squared over 28 plus 7y squared, I'm sorry, y squared over 28. And with that said, we have what? It seems familiar already. Familiar now, we have A and B. Which one is standard? Our standard form is this one po, okay? If you say general form po, most likely they are just in one statements like doesn't have any uh, denominator, okay? So our standard form here is this one. The one that I'm always showing. Even in circle, the standard form is where the radius is outside. Okay, x squared plus y squared is equal to r. That is the standard form. But if it's in general form, this is the general form because it shows 0. Okay, so if this is the case, let's continue this first. If we are going to look for the standard form already, we are not accepting that there are coefficients, correct? So we are going to remove that one by getting the multiples of it and cancel it with its denominator. What are the multiples of 4 that could divide 28? 4, correct? Okay. So we have x squared and 7. How about the other side? We have, what are the multiples of 7 that could divide 28? 7, correct? So we have y squared, then 4. Okay, because 7 times 4 is 28. Correct? Now, if you have x squared over 7 plus y squared over 4 is equal to 1, you can now proceed to find the ellipse. Correct? That is for ellipse first. But what if this is the case? Because you're telling in general form. What if you just saw a general form for the ellipse, just like 4x squared plus 7y squared minus 28. You will notice naman the difference between circle and your ellipse. As you notice, in circle, there are no coefficients, correct? Even though you will have h and k, if your circle has h and k, it will just seems like, for example, x minus 3 squared, no? Squared plus y plus 2 squared minus 4 is equal to 0. This is still a circle, okay? Because they don't have any coefficients like 4 or 7, okay? As long as it doesn't have any coefficient, that is circle. But if you have already, that's the time. That's the time that it will become ellipse. Okay? Or if it has both squared, but what if it is in parabola? Parabola. All right. So in parabola, we only have standard forms and general forms, isn't it? So what are the general form of ellipse? We have two. We have the vertical, which is x squared plus d. What was one? dy, I guess. I will be teaching you the quickest way. Squared. This is the standard form first. X squared is equal to 4c y. Sometimes it is x squared is equal to negative 4cy. This is from the table, ha? And y squared is equal to 4cx. And y squared is equal to negative negative 4c. There you go. So this is the standard form. How are we going to know if it's in a general form? So most likely, it will become just like this. For example, x squared minus 4cy is equal to 0. Okay? So the 4c has a value. For example, let's just get this standard form. Standard form of that one could be x is equal to 8y, correct? And 8y in standard form, this is the standard form. If you're going to convert that one in general form, it could be represented as x squared minus 8y is equal to 0. And if you will notice, what are the differences between parabola, ellipse, and circle? Ellipse and circle has what? Degree or the square in both uh, variables, correct? But as you notice, the power of just have x minus h squared, okay? Then 4cy minus k. Then same goes by. That is just the same. Squared is equal to negative 4cy minus k. And y squared, I'm sorry, y is equal to y minus k squared, then equals to 4c x minus h. If you will notice, it is just the same. Wherever the y goes, the k goes as well, no, with the y. So this is the one that I mentioned, like in the increments, isn't it? That it is really important for us to remember the values of each and k po. So in this case, you have the centers. They have values already, no? So in this case, if this is the standard form, could somehow see as well the general form. Oh, let's just use this one as well, ha? Oh, if you have the value of x minus 3 squared, is equal to 12. Y minus 5. Okay. So this could be represented as the standard form of your parabola. Okay. But what if it will be in general form? It will be in general form as x minus 3 squared minus 12. Okay. Minus 12. Uh, this one. 12y minus 5. Okay, is equal to 0. Okay, are we clear with that one? I do hope that we are clear, ha? Okay, it seems like you are just playing with the equations. Okay, in order for you to have the standard form and from the general form. Okay, are we clear? All right, so I hope that we are clear with this one. Okay, just wait. Okay, so okay. So let's have our discussion already in Hyperbola. Are you ready? So yung videos po kanina nasa YouTube nyo. Yes. And I did post that one in our Google Classroom as well, the link. No? So let's have the Hyperbola already. Are you ready? Or do you want that let's practice the parabola, ellipse, what? Ready? Hyperbola? Sige po. So, if you will notice in circle, so that you will have a guide, ha? In circle, what are the things that you need in circle? Let's put C. Circle for C, ellipse for E for ellipse, P for parabola, and H for hyperbola. Okay? So in circle, you only need center and radius, correct? Okay. So in ellipse, what you need in here is the center. You put center, ha, not C, because C is different. Center, the vertices, the foci, the co-vertices, okay? And obviously this one only. But in order for you to find the vertices, you need A squared, B squared, or A, B, and C, correct? All right. So what is the formula? In order for you to find the value of C, what is the formula? The formula is C squared is equal to A squared minus B squared, correct? So in parabola, the only thing that you need is the vertex. Vertex, vertex, not vertices. Vertex, focus. Focus, not foci, because we only have a reference point, only one. And the directrix, and the latus rectum. This is LR. Latus rectum. And that one only. Yeah. But of course, no, in order for you to find the focus, you need the force. Okay? And the value of C. Okay? Because LR is the value of LR, the distance of LR or latus rectum is 4C. And the value of focus is just C. So it's interconnected. Okay? So for your hyperbola, what you only need in here are the vertex. Let's put center. Center. Uh, Focus. Let's try vertex muna po. Vertices, no, vertices. Focus. Okay, so let's try to put co-vertices. Co-vertices. Then, if we have A, B, C in here, so most likely it is just the same, A, B, C. A, B, C, no? But, sorry. but there are difference between the letters. Just that the vertices would represent something later. And what else aside from this one? Asymptotes. Okay, asymptotes. Um, okay. What else? Only that one, I guess, so that you will not find it hard. Okay. So this is the guide, some of the guidelines. Like there is a pattern, and as well as in order for you to find the value of c, isn't it that I mentioned in ellipse, it is somewhat a Pythagorean theorem. But the only matters in ellipse is that the operation between a and b is subtraction. So in hyperbola, it is in Pythagorean theorem. So c squared is equal to a squared plus b squared. Mhm. So it only says that in your ellipse, there's only one vertices that has the greater value, or there's only one axis that has the longer axis, no, or the longer distance, compared to hyperbola. Okay, in hyperbola, you can tell that your co-vertices or the vertices below are just equal, okay, are just equal, or someone is higher or someone is lower, either way. It means in parabola, in hyperbola, it could be anything. But what is our tip in order for us to know whether the equation is hyperbola or ellipse, because they are somewhat the same. In ellipse, I will be telling already. In ellipse, we have x squared, then a squared plus y squared, then b squared is equal to 1. Correct? Correct. And sometimes, if the principal axis is at b squared plus y squared and a squared is equal to 1, correct? So this is when the principal axis is at x, because a squared is at your x. Then this is the principal axis when your a squared is at y axis po, correct? But in hyperbola, you could really see already if it's hyperbola. If, for example, no, the denominator, you have a squared, b squared, okay? Then the first fraction that you will always see is always positive. So this is x squared minus y squared. Okay. The difference between the two is that the operation in ellipse is positive, then the operation in hyperbola is negative. Okay? Then, this is when the axis that you're referring later, I will be telling, no, is when it's in x-axis. Okay? X. But what if it is in y-axis naman, no? So, sir, can you repeat the operation? What operation po? Yes, you may speak po so that it will be, the difference. You will see, this is the one. You will see what is the operation in ellipse. Isn't it that there are two fractions, the x and y, correct? So the operation between them is addition, correct? But in hyperbola, the operation is subtraction. You will only see that the operation in ellipse is addition, then hyperbola is subtraction. Okay? So this is the thing. This is for when the axis that we are referring is at x, and when we are referring to y, denominators will not move. In hyperbola, the numerators are the ones to move. Okay, so it will be y squared over a squared minus x squared over b squared. Okay? Okay, ha? But it is always just equal to 1, ha? They are just simply the same. The only matter is the a squared and b squared are not going around or not changing. The numerators are the ones changing position only. Okay? And they have the operation of subtraction. Okay? Are we clear? Clear, ha? Sige po. So let's continue. So once again, the objectives of this one is to write a standard equation of hyperbola, and we're going to graph hyperbola and identify its center. That's the one that I'm telling. Vertices, co-vertices, foci, and asymptotes. Okay? Okay po. So I have here given, I do have a given here. Okay, so in this case, we have a standard form. Okay, standard form of hyperbolas. Okay, and with this standard form, I did teach you a while ago how to make it in general form, how to convert it in standard form, correct? So if I will be asking you, what would be the general form for number 1 po? I will be asking, let's try Aldea. Let's try po. Go. Sige po. Oh, you try Try niyo sketch paper. How about Carl Justin po? We're going to convert that to 1. Carl Justin, can you hear me? Hmm. 10A, it doesn't mean that the meet is under 10 minutes already that you will be leaving already, because that is not sign of respect. You know that one, and you know what's the official time. Carl Justin, can you hear me po? You don't have any response? Carl, are you still with us? Oh, let's try. Let's try others, no? Let's try, how about Jody? Ramos? Can you hear me, Ramos? 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 10A, are you still alive? People of the Philippines. Yan. General to standard. General to standard. Oh, how about the standard to general? A while ago, I did, this one. I did give an example for standard to general. What are we going to do? So if we make it in standard form to general, think of the process. Like, how were you able to get from standard to general, the process? If you multiply, you divide, correct? When you multiply it, in order for you to find the final answer, so in checking, like in the reverse method, you're going to divide. Isn't it that in basic quadrants, you have this for fundamentals, this is for addition, this is for subtraction. So when you add, by checking, you subtract. Just like in general form, when you add something, going to subtract. Okay, for example, you're going to add all in order for you to find the general form. Then, when general form to standard, you're going to subtract. Just like that one. Okay? How? Thing to add. Sige. Please listen We're going to, yes, okay. Dea, 4x squared minus 9y squared is equal to 36. Okay, so the answer is correct. Okay, so how did we get it? Okay, how did we get it? OMG. Okay, so in order for us to find what is the general form, this one. If this is our general form first, isn't it? That I taught you, general to standard. What are we going to do is to divide this both sides. Then divide. Then you divide as well, correct? Or you can just simply write it as this part. 36, 36, correct? So, what happens here is that we find the lowest term, correct? If you divide in basic operation, if I told you, when you add, in checking, you subtract. When you multiply, in checking, you divide. Then sin goes by. When you divide, in checking, you multiply. When you subtract, in checking, you add. So sin goes by in here. So general, when you divide, okay, when you divide both sides in 36, you multiply it by 36. But how are we going to find if we should multiply it by 36? First is to find the LCD. Okay, least common denominator. How are we going to find that one? You multiply both denominators. If you multiply both denominators, what is the product? 9 times 4. It is 36. So it's 36 already. We're going to write that. 36. What's the operation? Subtraction. You just put. Now 36 divided by 9, what's the answer? 4. 4 multiplied by x squared, the answer is 4x squared. Okay, 4x squared. Then this is your operation. How about the other side? 36 divided by 4, the answer is 9. 9 times y squared, the answer is 9y squared. Okay, 9y squared. Okay, then once you multiply it by 36, correct? Once you multiply it by 36 already, what are you going to do? Think of something that you could diminish this 36 because in general form, correct? In general form, it always looks like straight or what else one? One line only. It doesn't have any denominator. So what are we going to do? We are going to cancel this 36 by multiplying, this is 0 ha, we're going to multiply both sides by 36. 36. We're going to multiply it by 36. I'm sorry. This is equal to 1. This is 1 this is 1. So we're going to multiply both sides by 36. So in this case, if you have already 36 as your numerator, because you're going to multiply that one, you could now cancel 36 in your numerator and denominator, and you will have 4x squared minus 9y squared is equal to 36. Correct? Gets already? Gets ha? Sige. Alright, so with that said, this way. You only have 1 minute this way. 3 minutes in this case. So this is the general form for the second one. So if you will notice, you multiply 25 by 16, it's just the same. Then you find the LCD, find the numerators, and you cancel the denominator that you got. And with that case, we're going to stop here, and because this is the last meeting in calculus. Later you attend. All of the grade 10s are required. Please watch the video for this continuation for the hyperbola. Okay? So that you will not miss this hyperbola. And okay, so let's end this meeting already. May I request to everyone to please open your camera? Alright. So let me have your smiles.